Welcome everybody, and thank you for joining us in this evening. Today we'll have a closer look at the polymers that in a later stage of their production process look like this. So then they are called buttons or blanks, and your specialty lens manufacturer produces these little wonders from them that make patients around the globe very happy. I hope you can see it, but you all anyway know how a lens looks like. My name is Tanja Markus. I'm from Bausch + Lomb, Boston Materials. I'm the regional manager for Europe, Middle East, Africa, and India. And it is my pleasure to greet you all tonight and introduce our presenter for the evening. But first, I just want to take a moment to recognize that in today's current climate, we understand that you have many virtual learning opportunities, and we're so pleased that you're able to join us tonight. Without further ado, I would like to introduce tonight's speaker, Dr. Maria Walker. She's going to talk with us about the materials that go into manufacturing gas-permeable lenses and delve into the material properties and the manufacturing process. For those of you who don't know Dr. Walker yet, she attended the New England College of Optometry in Boston, Massachusetts, where she earned her Doctor of Optometry and Master of Vision Science degree, and then went on to complete her residency in cornea and contact lenses at Pacific University in Forest Grove, Oregon. After her completion of the residency, Dr. Walker joined the faculty at the University of Houston College of Optometry as a visiting clinical faculty member. She's currently part-time faculty at the University of Houston, where she is also pursuing her PhD in scleral lens effects on the eye. Dr. Walker has extensive experience with specialty contact lenses and has lectured and led workshops on scleral lens fitting around the world. So with that said, let's jump right into the program, and I will go ahead and turn it over to Dr. Walker.
Thank you very much, Tanja. It is an absolute pleasure to be here. I know it's evening for many of you, but as you can probably see, it's still daytime here. It's lunchtime here in Houston, Texas. So, you know, there's lots of things we can complain about with the COVID and everything, but I think one benefit is being able to, you know, feel like I'm in the same room with people on the other side of the world. So it's really, really fun to be here, and I'm excited. So this is going to be, we're going to talk about the actual materials that we use for corneal lenses and for scleral lenses. You know, there's lots of lectures on fitting lenses and managing patients. And I think sometimes we forget about really the kind of core, looking at the actual materials of the lenses that we're fitting. And I think the more you know about the actual materials can be empowering in how you fit patients, because if you understand some of the pros and cons and some of the background information on how the lenses are made. I know Tanja showed you a GP button. If you weren't able to see it, we'll show some of those here in the slides. But you know, to start with, you know, what the actual marketplace for GPs are. And, you know, I'm a bit envious of you in Europe, because I know that you guys are the ones that make this percentage of all fits kind of increase up a little bit. So here in the US, we actually don't fit quite as many GP lenses. We're at about 10%. I think Europe is closer to 20%. So you guys are pulling the curve up a bit, but globally, we're talking about 13% of all the fits. And I know you guys, like many things in medicine, sort of happen in Europe before they make it over here. So, you know, I really hope that you guys, that we'll see more and more GPs, and especially now that we know how beneficial they can be. We've gotten really good at manufacturing corneal and scleral lenses. And now we've got orthokeratology trying to manage myopia in all these kids. So I don't think we're going down in this category. I think if anything, we're going up, and hopefully that's something that's consistent with what you're seeing in your practice. Lots of different applications, of course, for gas permeable materials. So maybe the most exciting one, I certainly think, well, I guess I'm caught between orthokeratology and scleral lenses being among my favorite devices to manage patients with. So we can manage myopia with Ortho-K. We'll talk a little bit more towards the end about the specific materials, because Ortho-K, certainly Ortho-K and sclerals, this is where we really have to think about the materials, because these are lenses that are, in the case of scleral lenses, a bit thicker. Orthokeratology is worn at night and worn on kids. So for those two types of lenses, we tend to really think a lot about the DK, and we'll talk about the different options and the pros and cons of higher and lower DKs. I saw there was, I think I had a couple of questions that people were able to submit early, and the theme of that was, okay, great, now I know about different types of materials, but how do I actually choose which one to use on different patients? So hopefully you'll leave this hour with a better idea of that, and why we choose certain materials for certain indications, and why certain indications maybe we could use different materials and it doesn't make a big difference for the patient. So orthokeratology is a big indication. Post-surgical irregular corneas, I probably don't have to convince you of that. The rigidity of the material can neutralize a lot of those irregularities. So vision being a big key. So visual quality, and even on our normal cornea. So patients with presbyopia and astigmatism being the main ones we focus on, because those are the patients who typically start to have some challenges with their soft lenses or other types of lenses at correcting their condition. And we know that the really good optics of gas permeable materials, those harder plastic materials, is what drives some of our, quote, normal patients into wearing these rigid. Dry eye diseases, soft lens refits, these are probably more of our scleral lens patients. If somebody's got really dry eye or comfort issues, I'm not typically going to go to a corneal GP. I can go into the scleral, but we'll talk a little bit more about these as we go. And I think we already probably understand this and have established it, but quality of vision being really key in terms of why we typically use GPs. But there's also lots of benefits that maybe that's not our primary reason, but lots of benefits to fitting GPs in the practice. Kind of the biggest ones being in patient retention. So these are patients that you're not going to give a prescription and have them go buy it online somewhere. Typically. So you're going to keep these patients in your office. Not everybody's able to fit these lenses. So you kind of specialize yourself into this niche. So starting a little bit at the beginning, because I think this is something that we all take a little bit for granted, and yeah, there's these lenses that are great, but how did we get there so that we, have these the ability to use these materials? And I know probably once or twice a year, more often than that, maybe once or twice a month, I get a patient who's just curious about where these plastics are coming from. Actually, a couple of years ago, I had a guy who worked on plastics for Coca-Cola. So he was literally a plastics chemist. So you can imagine he had a lot of questions about what the actual material was. So it's nice to be able to discuss this with patients if they're interested and have it in the back of your mind. But long story short, these plastic materials are made of what we call a polymer. And a polymer is just a combination or collection of monomers, right? So here's a little image here. Just imagine one of these little balls of the monomer. You put a bunch of them together, there you've got a polymer, right? We know the prefix mono, poly means single versus a large number of units. And so that when we say polymer, people who are who know about plastics know that this is a ubiquitous term, but it can get some of us twisted and not knowing what this relatively unfamiliar word is. So when you hear people talk about the polymer, think about that's the material, that's the base of the material, is whatever that polymer is. And again, we won't go into the chemistry. That's certainly out of the scope of what we need to accomplish here. But having an appreciation for all of the work that chemists did to make lenses that basically have these 4 characteristics on the bottom here. So they have to be transparent to light, of course, right? Seems simple enough. Refractive index suitable for bending light. So the refractive index on most of these lenses is about 1.4 to 1.5. So that's a suitable. You can't have it too much different from the optical refractive indices, or else the light just gets bent too much, and that can cause distortion. And then we know really the biggest obstacle in developing polymers that we could use is the oxygen permeability. So the gas permeability of these lenses, which we'll talk a bit about, is probably the primary characteristic that we consider when we're figuring what lenses to use, because that's the DK value, right? The DK is that oxygen transmissibility. And then, oh yeah, they have to be easy to clean, comfortable on the eye, biocompatible, right? So there's a lot that goes into this. And there's certainly been a ton of evolution. And so 150 years ago, when the first contact lenses were being designed, those were in glass. And actually, those of you who are in Germany or the UK probably had these were being done potentially right close to home for you guys, but just a lens here and there, mostly scleral lenses. And it was really not, and then in about the 1920s, you started to see PMMA, this polymethyl methacrylate, great piece of plastic, rigid, resistant to deposits, really resistant to warpage as well. But as most of us know, no oxygen permeability. So basically, lenses that we have now are PMMA with a bunch of other stuff added, mostly being silicone and fluorine being the primary elements that were added to PMMA to allow oxygen permeability and a good wetting lens. So that's where our fluorine comes in, because silicone will have a high oxygen permeability, but it won't allow the lens to wet, right? Silicone is typically a pretty hydrophobic material on its own. So you add fluorine to that, over 10 years of chemistry, and they were able to get a lens that wets properly, has enough oxygen permeability, and is compatible with the eye. So here's our timeline, and here we are now in the 2000s, right? Silicone just came into soft lenses 20 years ago, but basically we've been working with pretty similar materials for gas perms for over 20 years at this point. Constantly you're seeing these little evolutionary, we add a little bit of this and it becomes a little more deposit resistant. So you're seeing some kind of what I would consider microevolution. But basically for the past 30 years, we've had fluorosilicone acrylate lenses. And why is that oxygen so important? Well, again, this is, a reminder, certainly not an introductory lesson unless I've got some students here on the line, but the cornea is avascular, right? So it's really important, especially if you've got diseased tissues, to get oxygen exogenously or from the air through that cornea for proper metabolism. And we all know this bottom layer here, our endothelium, And so the endothelium is really what you want to focus on in terms of determining whether or not a patient has a healthy cornea in terms of oxygen metabolism. So we know that there's 5 layers of the cornea. The endothelium is, of course, the layer that's responsible for maintaining the hydration and for maintaining the thickness of that cornea. And when hypoxia occurs, that endothelium gets stressed out, and in extreme situations, it can't keep up with the metabolism. So that's really, I think, my first step when thinking about what material is most appropriate for a patient, right? So there's sort of different ways, different properties that you're going to consider. You're going to have some lenses that dictate what material you use, and you're going to have some patient health that dictates the materials. So if you have a patient that has endothelial compromise, damage to their endothelium, oxygen has to be #1 priority in the lens. And so you're going to go with a higher DK if you've got patients with endothelial disease. And we'll talk more as we go here about what types of patients are appropriate for what types of lens. But #1, patients who have compromised endothelium, whether it be from a disease or whether it be from like Fuchs endothelial dystrophy, for example, or if it is a condition like a transplant. So if a patient has had keratoconus and have subsequently had a transplant, the transplant is, you might as well have endothelial disease, because transplanted corneas lose endothelial cells, and we know that we don't regain endothelial cells as you go. And so those are really the 2 populations. Patients with endothelial disease and post-transplant patients are highest DK or a higher DK for the lens that you're using would typically be most appropriate. And I've already obviously talked a bit about oxygen permeability and transmissibility, and we'll talk about the difference between high DK materials and low DK, because another question I get asked a lot is, well, why not just fit everyone in the highest DK material? That seems logical. And you know, for some patients that might be the case, but for many patients, you want to balance some of the other characteristics of the lens, because when you make a lens DK greater and the oxygen permeability greater, you can think of it as making a sponge more porous. That's always what I use, right? So the higher DK, the more porous that material is going to be, the softer that material is going to be. So softness of a lens may make it flex a little bit on the eye, depending on the design. It may make it more susceptible to deposits and certainly to scratches and things like that. So we'll go back to this as we go, but be thinking about, it's not just about the oxygen permeability. It's sort of, you get some properties and you may have to kind of wax and wane on the other properties. Surface wettability, we'll talk more about. Flexural resistance, right? So when I say flexural resistance, that's how soft is that lens, right? And hardness, right? Hard softness of the lens, but the flexural resistance, right? You have to think of how thick is the lens and how stiff is that lens. What's the modulus is the term we use of that lens. And then UV absorbers, which we'll mention. So let's think about the type of patient that's going to go for a low DK material, which are a lens that's more rigid, right? Less prone to scratching, deposits. So patients who are really rough lens handlers, so that tends to be the male population here in the United States. I imagine it's pretty similar in other areas of the world. These men, rough, we've got here in Texas, we've got people who work on oil rigs and go out sailing for weeks on end, right? Those are rough lens handlers. Patients who have really high blur sensitivity, maybe you think, okay, lower DK, but you also want to be thinking healthy eye, right? So healthy eyes don't have don't need to have these super high DK materials. So I think healthy eyes, then I also think a thinner lens. So for example, a corneal lens, right? A corneal GP lens is, even if it's a high powered lens, it's still going to be substantially thinner than a scleral lens. So low DK materials are for corneal lenses. So scleral lenses are out. You don't go low DK for scleral lenses. And we'll, towards the end here, I'll show you exactly what the DKs of the different Boston materials are. And so these are going to be for these healthy eyes, corneal lenses. So these are your everyday, you got a 10 diopter myope who's in corneal rigid lenses. They will do great with this low DK, really stable, stiff material. So like this guy here, right? He looks young. We're going to just assume he's got healthy eyes. He's an architect, so he really needs to see, he's really sensitive to any amount of blur. So this is your guy to go into a low DK. Given, it's certainly assuming that he has a healthy cornea. Now, what about the high DK materials? Well, like I had mentioned in the beginning, and we'll go back to now, there's two lenses, actually three types of lenses where you're automatically going to go to a high DK. But again, scleral lenses, overnight lenses, right? I don't have to convince anybody that overnight lenses should be in a high DK material, just as if this is a reminder of that. Piggyback systems as well. Think about the thickness of the system. So if you have a piggyback, I don't know how much y'all do piggybacks over there in Europe, but we do them a decent amount. Not so much now that we have scleral lenses, but sure, we still do it. And when you're piggybacking, I always say, let's go to a higher DK material, again, 100 or greater. If you've got really high refractive errors, and I'll say specifically, this is a high plus refractive error, because the high plus is when your lenses get really thick. High minus doesn't typically get that thick. You might have a little increased thickness in the mid periphery, but usually that lens gets cut off before it would get really thick on a minus lens, which would be thicker in the periphery. The central thickness is going to get really high with your plus. So that's where you go. You're right. Keeping in mind that when we talk about DK, that's a general property. We have to think of DK over T, right? So if thickness of the material, and that's the reason for scleral lenses, but also these high plus lenses, if the thickness of your material is increasing, you want to increase the DK so that you have, a lower DK over T at the end of the day. Keeping in mind, these lenses are going to scratch easier and they are going to be more prone to deposits, but sometimes you say, we have to put you in this material anyways, even if it's your rough and tough guy who's not handling lenses. They just simply have to replace the lenses more frequently. But you can give them little tips to reduce. So kind of to summarize choosing the material just generally. So you can see here, again, you've got a corneal lens here, a scleral lens here. So corneal, typically I'll fit with lower DK. The scleral I'll fit with a little higher DK. So remembering that the higher DK is going to be a little softer. The other comment I'll make here, and I brought up before, is this flexure, right? So if we have a higher DK, lens can be a little more flexible. Now, here's the good thing to remember. A scleral lens is quite thick, right? Usually 250 or more microns in thickness. There are people who will say scleral lenses flex. I'll tell you, I've never seen it. So I am not so sure about the flexure of these lenses because they are really thick. So that's a good thing, right? You've got this higher DK, so people maybe get worried about flexure, but it's a thick lens, so it's not as likely to flex. Now, a corneal lens, on the other hand, is going to be substantially thinner, typically about a third of the thickness. So a corneal lens might be about 100 microns in thickness. Now, that is going to be a thinner lens. So if you have a really high DK in that lens, it might be more susceptible to flexing on the eye. So these are the things you're kind of balancing between. So I would say, as a general, I think lower DK for corneal lenses, higher DK for scleral lenses. And, you know, keeping in mind, if I do go higher DK for a corneal, I may have to consider that the lens might flex on the eye. And then, so the factors that we consider, which we've really already gone through, is what's the oxygen availability, what's the status of, what's the health of the patient, and what's the type of lens that we're actually using. So wettability, we'll go through here, and wettability is interesting because in terms of choosing a material, this is not going to be, wettability is not going to be on your brain, really, because the wetting, so you're going to get what, a wetting angle from the manufacturer. Well, the wetting angle doesn't really predict the wettability performance of the lens on the eye. And the good thing about modern materials is they're manufactured and they're treated in a way that they typically will all wet on the eye. And when they don't, it's usually an issue with the patient's tear film, right? Because remember, they put the lens on, their tear film interacts with the biofilm at the lens surface. And so if you have a lens that's not wetting or that's getting a lot of deposits, think, what am I using to clean this lens? Am I getting the lens clean enough? And then what's going on in my patient's tear film? Do I have lots of debris, lots of lipids, oily deposits that are getting on the lens? So typically when you've got an issue of wettability, it's not necessarily that you need to change the lens. You may need to change the types of cleaners and the types of cleaning protocols that patients are using, because oftentimes it can be traced back to that. Then again, just to show you, you know, if you look up the lenses, you'll find a wetting angle. You know, and it'll be a smaller angle if the sessile, you know, if a drop of water on the material spreads out more, okay, that's good, versus beads up, okay, that's not as wettable. But like I said, this is really academic, and these are just the sessile drop, captive bubble, Willemy plate. Those are just techniques used to measure the wetting angle for your information, but they're really not something that you've got thinking in the top of your head. So if you've got issues with wetting, think cleaners and think patient hygiene. So again, just to kind of, you know, keep kind of circling back to this, when we're talking about material selection, if we're worried about the wettability, I'm not particularly thinking much about the material. If I was, like certainly with deposits, it would be those higher DK materials that are going to be, you know, that spongy. You can think of them as spongier and stickier too. They're just this soft material, so stuff sticks to them a little bit easier. And so if you do have a patient who's got a lot of deposits, not so much the non-wetting, but if they have a lot of deposits and certainly like clumps and things on the lens, that may be an indication that as long as their eye is healthy enough, go into your lower DK ranges. So why choose Boston? We talked a lot about characteristics, so let's talk a little bit about specifically the Boston materials. And I think the greatest reason to use any materials, they've really stood the test of time and have a real history of being on the innovative front line in terms of what the materials are that are being used. So they acquired polymer technology back in the early 80s when gas permeable lenses were really starting to take traction. And you can see all the way up into 2019, every couple of years, really taking a next step to either introduce hyper DK materials, high DK materials, when things like scleral lenses and orthokeratology became more widely used, and as well as, you know, working to get kind of all the newest technology on the lenses, and just being a lab that has so much oversight and has been doing this for so long. You really can trust the products that you're getting, which I think is great. And just to give you a rundown quickly of the actual process, you know, it started when, you know, how we started this lecture, kind of, you know, talking about the monomers, working with methyl methacrylate and polymethylmethacrylate, and silicone and fluorine, right? So there's constantly this ongoing testing of chemical monomers to help improve the actual base materials of the lenses. And then, the polymerization process, the mixing of all those heated plastics together to really form the final button, if you will, the rod of plastic that gets cut into those buttons. And then gamma radiation process to help, get those final characteristics and reduce the impurities in the lenses. And then you've got your final GP. So if you didn't see what was being held up earlier, you can see here are those buttons, right? So basically this is what shoots out, and you've got the different types. And so here I'll share with you what the different DKs are. So here's 4 different types of DKs. You can see we've really got the different range to meet the needs. So as low as 18. So this low 18, that's your really, really rough handler. And so those are your patients where they are only wearing lenses during the day. And I would say I probably don't go down to this low DK as often, because I find that the DK of 58 works really well as a low DK. But if you've got that patient who's a super depositor, scratching their lenses, really needs that lens to stay solid and not run into issues of the softness of the lens. And again, a key daily wear only. This is the one where you really don't want them sleeping or closing their eyes in the lens. You could do Boston EF all the way up to Boston XO2. So I think that you've got a different lens for every different indication that you need. And so that's the Boston line. Again, these are all things that we went over, lots of different things available with them. And so different indications for each. All right. And so just in general, Bausch & Lomb, lots of awards and excellence. Again, this is another reason that this is a good kind of workhorse lens company to use. And so you've got lots of different awards that have been offered because of good quality assurance lenses. So it's very important to have materials that are reproducible and reliable. And so winning a lot of awards on the actual material side of the awards. And of course, has all the certifications and quality control, ISO certifications, international standards, and has all the stamps of approval certainly necessary. And lots of different opportunities for education and training. So things like what you're attending right now and learning a little bit more about the materials. So we've got webinars. There's lots of literature, so ask your reps about this. Lots of different materials on actually fitting as well, right? So this lecture is focusing on the materials, but we've also got lots of education on, okay, now that I've chosen a material, how the heck do I fit a scleral lens, or how do I fit a presbyopia lens? So check out that education, certainly if you're interested in. And then one of these days, we'll get back to live training events. I know I love these live training events and actually bringing patients in, putting lenses on eyes and seeing the difference that they can make. And so I would encourage you, if you're just getting into or increasing your gas permeable lens practice, it's a great opportunity to bring a patient in, get your representative in there, and actually fit some live patients. So maybe in the next year, hopefully we'll get more live training events available for you guys. So a whole global team is here, able to support you. Lots of different programs. They can give you all the information on regulations, on what's FDA approved for which indication, and it can help you make all the decisions that you need to make for your lenses. So, contact us, be in touch, certainly. And we've got lots of different options. Just some brief safety information that we always want to remember when we're fitting and when we're managing gas permeable lenses. Any lens that is in it should be worn for the indication that you prescribe to your patient. So always being careful to communicate with patients that if they have problems like discomfort, tearing, redness, to contact you and to remove the lenses, and not to use the lenses in situations like inflammation and infection. Hopefully all of us have sort of a spiel that we run off to patients. Any redness in the eye with the contact lens is urgent until proven otherwise, and take that lens out and give us a call, and not put a lens in when you have these contraindications.
Please take a moment to review the important safety information in the following slides.
So thank you very much, everybody, for spending part of your day with us. And I hope to see you all in person out there post-lockdowns. Have a great evening. Bye-bye.